So this is section 4.4, and this is a particular technique called analysis of variance. And for short, people say ANOVA. And the whole idea here is that we want to compare two variables. We're looking for dependency, as we were doing in chapter 3, looking for prediction, dependency, independency, dependency, okay, association. You know, that's the kind of thing we're looking for between the two variables. All right, so what's happening is our explanatory variable our explanatory variable is categorical. And our response variable is numerical. So that's the difference between 4 and 3. In chapter 3, both variables were categorical. Now we have an explanatory variable that's categorical, a response variable that's numerical. And so our data would look like we'd have our different categories, category 1, category 2, category 3, up to category N. For this particular method, we have at least 2 categories. We can have as many as we want. And then the way I'm going to name this, I'm going to call this x11 for column 1, and then variable 1, x12, x13, and so forth. Okay, and then we could have an x21, x22, x23, x24. Don't have to be the same number of observations in any given column or category. x31, x32, and so forth. xn1, xn2, and all that. Okay, so that's what we're trying to do. Now, I can just plot these, and so in chapter 3, we used a table to kind of summarize our data and see what was going on, and we could look at the numbers to try to figure out, do we think, you know, each row or each column of the table was the same? Well, here we're looking at these columns. I want to know, do each of these columns seem to be about the same? Well, we can do that visually with a box plot. And so that box plot is just a 5-number summary, and it will have the minimum, the maximum, it will have the median, and, you know, so let me, for each of these, you know, I could have something that might look kind of like this, and, you know, so there's the median, here's the max, here's the min, and then remember we had the interquartile range, and that is what is going on from here to here. Oops, get my arrow in there. But this is the IQR, the interquartile range. So this is Q3 and Q1. So that's what a box plot shows. And if, you know, these things, you know, visually, if I see something like this, now you don't have to put these horizontal lines at the top and bottom, but, you know, if I see something in my box plot that looks kind of like this, where these things, all look quite different, yeah, visually, I'm going to kind of guess that, oh, maybe there's a difference. But if all these box plots look pretty much the same, I think there's maybe no difference. And that's our question. Is there a difference in the columns? In other words, so when we think of back here, prediction or dependency or association. So prediction, right? If I'm guessing sort of what's going to be my numerical outcome, these x's, does it make a difference to me whether I'm in column 1, column 2, column 3, column n, right? Does it make a difference? Will I create a different prediction? And as I look at this picture down here, I probably would make a different prediction. Because if I'm in column 1, I would expect lower values than in column 2, but higher values than in column 3, and so forth. So it would affect my prediction. So another way to look at it is, are the columns here dependent or independent in the sense of variable? I got to be careful with that when I talk about columns. So are the two variables dependent or independent? And again, it's a matter of, the one variable, the explanatory variable is these categories. Does it matter what category I'm in? And again, from this picture, it looks like it does matter what category I'm in. And so I would call that dependent. If all these box plots look the same and we're kind of all on about the same level and so forth, I'd say, oh no, it doesn't matter what column I'm in here. I don't care if I'm there or there. And so in that case, they're independent, or the variables are not associated. Okay, so it's these same questions, but now instead of a table, because both rows and columns are categorical, now you could say only our columns are categorical, but as I look down the rows, I've got a bunch of numerical values, and so I need to get those averages. So that is what we're doing with this analysis of variance. And how do we go about that? What's happening? Well, what we're going to do is actually, it's called analysis of variance, and so you think about the variance or standard deviation. But actually, what we're checking, the null hypothesis, has to do with the means. And so the null hypothesis is that for each of these columns, mu1 is the same as mu2, is the same as mu3, is the same as mu-n. All columns have the same mean. That's our null hypothesis. And HA is at least one is different. Oops. Okay, so at least one is different. That is our null hypothesis here, and then our alternate hypothesis. And based on this null hypothesis, we'll generate a p-value, and if that p-value is small, we'll say, hey, our data do not support that. If the p-value is big, we'll say the data do not give enough evidence to refute it, okay, or to go against it, right? We would fail to reject it. So again, that's the same. It's just the actual mechanics of the test and what it is testing. And so now in the chi-square test of independence, we were saying that those relative proportions across columns were all the same. Oh, okay. So see, it really is very similar. This is just a little more general because a proportion is a mean, but these are a whole bunch of means, and, or a whole possibility of means, right? Proportion is a particular kind of mean that comes from count data. But these means can come from all sorts of different numerical data. Okay, so this is more general in that sense, but it is that same idea. Okay, we're just wondering, does it matter what column I'm in? Okay, so that is this analysis of variance idea, and in the next video we'll kind of look at what it is we're doing, what we're checking in the analysis of variance, and kind of come back to this picture to kind of see what we want to do there.